And so this actually leads us to our ROC curve. So our ROC curve is kind of like our I had to look this up because I could never remember this receiver operating characteristic curve, which again, in my opinion, does not really clear up anything. Usually I'm pretty good at like taking words apart. I'm like, I don't even know where this came from, to be quite honest, the history of ROC curve. But no, ROC curve. So a ROC curve basically allows us to kind of, in this kind of show a little bit in a bit, but basically combine multiple comparisons together. And so one thing we can use a ROC curve for basically is to realize that we can kind of like do the opposite. Like, okay, so like I'm trying to clarify myself. So like the worst kind of classifier, the worst kind of guesser in a lot of ways is actually someone who just guesses, just randomly guesses, like, I don't know, it's an A, I don't know, it's a B. So the worst classification basically would be that it would get 1 out of 24 in this case, or in the case of these ones, it would be 25% of the time it just gets to 0 and 24% it gets to 1. So that'd be like the worst kind of like model classifier. It turns out though, this is kind of an interesting one, is that a bad classifier, so one that actually always gets it wrong, could actually be a better classifier, because it's kind of like, I gave this scenario of like if you know someone who always hates the movies that you love, it's good. You can always ask them, say, hey, what movie, like, what do you think of, let's say the new Lion King? And they're like, oh, it was an awful movie, I don't want this. And oh, cool, should go watch that because you hate all the movies I like. So it's actually a really great classifier. So in a lot of ways, the worst you can get is not actually getting it wrong, it's actually just guessing. So something to kind of keep in mind in our classifiers. We usually don't have this issue where it's getting it purposely wrong, because usually it's like when we're training a model, we're doing it iterative, so it tends to do better and better, not worse and worse. At worst, it kind of just does it randomly, and it never gets any better than that. So just know that just kind of keep in mind, okay, that's what our classifier looks like. So that's how we can kind of judge what a classifier is. This is where logistic regression is that. If you want more detail, we could talk about this, but I'll kind of just quickly say is that in a logistic regression, we have a curve that looks like this, like kind of like this S curve, okay? And this goes from 0. If I drew this better, this would actually close to 0. Actually, I'm gonna rewrite all this because this will make it, this will bug me. There we go. Close enough. Okay, and right here is about 1. Okay, and so you can imagine if you have different data points. For example, I'm gonna write in, I'll write it in blue. So in blue, like this, pretend these are the ones that should be classified as 1. These are true. And this is some feature on the bottom here. Like we said, like weight before. This could be like heart disease. So it's like, okay, these ones are actually blue right here. So these are the extreme. And then maybe there's a couple right here, but most of them are over here. So basically, with pretty certainty, it's like if you're far enough to the right here, you're probably going to be classified correctly. Maybe there's a few stragglers over here we're not going to quite get. And you might have someone who's on the negative side. So I'll write this in, not green, I'll write it in orange, okay? So orange might not be the best color, but oh well. If we're on the far left over here, it's like, okay, these are mostly classified. And as we move further off to the right here, well, it's like, okay, maybe there's a couple that are off here, but most of them would be classified correctly, okay? And so remember that this ROC curve, or not this ROC curve, this logistic curve right here is expressing the probability. So if we say, okay, with this, let's say this weight right here, this weight would actually correspond to 50%. It's like, well, okay, that means there's a 50% chance that you'll be classified as this. And so what we can do is like, okay, like, well, what we usually do is we'll draw like a little line right here and say, okay, if you're above this line, okay, if you're above this line, we're going to classify you as, what's it called? As positive. And if you're below that line, you're negative. So when I say above that line, I really mean, I should really say like this. Oops, I'm trying to draw my line well. There we go. This is our cutoff. So we'll kind of say like, okay, at the 50% mark, everyone to the left of the line will be marked as negative. So this 0, and everything off to the right over here will be positive. If we adjust then, I shouldn't have drawn that first line. I think that's confusing. I was trying to show that's 50%. There we go. So if you imagine right here is the 50% mark right here, and say, okay, everyone to the right over here, this right here to the right, what means like, okay, you're gonna catch some people who really shouldn't be. If you drew the line, if you look at this point right here, and you drew this line, okay, you are much more likely to catch everyone who's negative. You're gonna say some of these people are positive even though they're not. And then if you had the extreme over here, so imagine this kind of line going out this way. If I looked at just like this point right here, and say the right here is like, okay, everyone to the right of this will be marked as positive. I'm gonna get one wrong, and I'll get all of these ones wrong. So this is basically what we call a threshold. It's kind of like, what threshold do you adjust? And we'll usually describe it like this little like dotted line. This is kind of why I went to that first. It's like we're saying what threshold of probability are we willing to accept? And this will actually determine then how well our positive and negative rates are, or true positives and our false positive rates. And we can adjust that threshold to basically say, well, how many people do we want to capture? If we want to do like 50-50, we just see the 50 line and you just draw a line in the middle and say everyone to the left over here, you're going to be negative, and everyone to the right over here will be positive. We can adjust that line though. It's like, okay, let's go consider that, closer to like 80%. It's like, well, okay, in that case, we'll have this line right here that intersects at the 80% line, and you'll start getting, you'll get more of those positives and stuff like this. If we want to go really extreme, we could try to go like, remember this goes on forever. We could go from like the 99.9% over here, and we say everyone to the left over here is negative, and everyone to the right over here is positive, right? So this is something that's like, okay, like, well, this will definitely catch all the negative people, but it's never going to catch any positive people. So this is kind of like a trade-off, and this we can keep adjusting this threshold. So one way we can do this then is actually draw out, and I'm going to actually kind of skip over this graph interpretation because this is me drawing. Basically, what we could do is we could actually, for each threshold, say, okay, what's the true positive rate? What's the false positive rate? I guess I will draw it real quick. And so you could basically say, well, draw. There we go. We can say, okay, here's our true positive rate, our false positive rate. And then we can make a point on a threshold. It's like, okay, let's say a threshold of like 0.1. It's like, well, we'll see that 0.1 is going to catch most of these going to catch most of these false or true positives, and I'll go through. It's like, okay, let's go here, go here, go here, and you'll actually see this kind of graph going through. And each one of these points represents a threshold that we're representing. Okay, and this helps us to figure out what threshold should we actually capture. Because ideally, we want to have all the true, very high true positive rate, but a low false positive. So ideally, we want like a point that's like at 1, get all the true positives, but have no false positives, right? And so this would be ideally right here, but we'll probably get something that's closer like over on this side and this side. And I'll show an example of this on a graph because I thought it was pretty cool from another website. Let's see here if I want to go to coding example. Yeah, we're gonna go to the coding example. So just know I'm gonna make this ROC curve here. All right, you know what? I'm gonna show you this one. This is what I want. Okay, so this is kind of nice. This is from another website. So this website right here has a ROC curve represented. And what's kind of cool is that as you adjust the slider, you can imagine these are all the ones that are true positive and false positive. So I can adjust this slider right here. Oh wait, I'm sorry. This slider basically saying, for example, there's some crossover where it's kind of like, oh, most people who are negative will fall into this range, but some are really extreme, and some are kind of crossing over into the positive range. And then people who are positive will be kind of over here. And what's this part here, it's this threshold. So this is 50% threshold. And so if I go through 50%, it's like, okay, everyone to the left of this will be marked as negative. And so that means I'm gonna get a little bit of this tail right here that was supposed to be positive. But on the right here, I'm also gonna miss some people who are negative. So if I wanna adjust this, like, well, okay, I want to just consider all of these people. It's like, okay, and then I get all of the negative parts, but I'm going to misclassify some positives over here. And what's cool is that this guy right here, you can see is our ROC curve, okay? And so this actually shows us what happens when we adjust this threshold. So when we adjust this threshold, this is basically plotting each point. So if I put the threshold right here, you can see that's where our ROC curve is. And just to kind of make it a little bit easier to see, let's say I have a lot of crossover, is that if I draw my threshold here, it's like, okay, that's a pretty good one. But as I move over here, okay, it's not that great. I'm basically over here, I'm basically getting no one, right? I'm technically getting these parts right here, but I'm misclassifying a lot of people as these are false negatives. So these are a bunch of people who shouldn't be negative, but I'm classifying as which. And I can adjust this threshold back and forth to basically find these points on this ROC curve. And so basically the ROC curve is going to represent all the different thresholds we could possibly do. and saying what that false positive rate versus our true positive rate is. So you can see here, this FPR is right here, this true positive rate here. This middle part, you'll notice, is like if there's basically no difference between the two groups. So you can see here is that if there's no difference between the two groups, it doesn't really matter what my threshold is because I'm going to be really close to this part. So you can imagine if I have this distribution and have some crossover, I'll never be able to draw any threshold that's going to perfectly split them in two, but I can get pretty close. Like, well, this is probably the best threshold right here. The thing is, you don't know what this is to begin with, so you're kind of trying to figure out what the good threshold is. So this is a way to adjust your threshold to figure out on this ROC curve what would be good. Yeah, so okay, so this goes into our area under the curve part, which is related to our ROC curve. And I'm just going to kind of show this part, is that we can use a logistic regression and we can compare logistic regressions with each other, so different multiple classifiers. So I'm just going to go ahead and use that same thing. And again, this is just a bunch of code that's in the notebook, but I'm just kind of showing this part off. Oops, did I not? Sorry, I might have to run some extra stuff first. This is probably why. So this is our first coding example. So this is our ROC curve right here, our receiver ROC operating curve. And this is for our different class points. And we actually have our different points here. And you can see here is that this one's actually probably have very little, a huge like difference between negatives and positives versus something like this. This one actually probably has a lot of crossover with that, what looks similar to a true positive and a negative. And I think there's a third one too. Nope, there is not a third one. Oh, it's a 0. You can see here, that's pretty easy to identify. But a good one's probably, not that one, this one. You can see, and these are basically the different thresholds of saying, identifying the true positive rate and false positive rate. Okay. And just to kind of show, these are all three of them together, which is not super clear, but you can kind of see that they're all together. And then this example of an area underneath the curve part, there we go, this is what I wanted to show, is that now we can actually compare multiple, what's it called? Our different classifications. So we can see here on our ROC curve, and say, okay, what we want is a good classification is going to have a very large area underneath this curve of the ROC curve. So you can see here is that this blue here actually does a really good job of identifying, you know, given the different thresholds, it actually does a pretty good job identifying what the classifications should be. Versus something that's over here, it's like, well, it's not doing a very good job. It's basically, you know, kind of guessing and might be a little bit better, but not much better. Okay. And so again, all of these little staircase points are just because there are different thresholds for each point that we can have. Okay. And that is kind of our ROC curve going to. But I think this one right here, to be honest, from this website, does a really good job of showing it, of saying, okay, if you adjust this threshold, that is each point on that ROC curve. And the shape of that ROC curve just depends on saying how you identify a true positive and a false positive. Like what are actual positives and what are actual negatives going forward. Okay. Any questions? I know I kind of walked through that a little quickly, but that kind of gives you an idea of at least what the ROC curve is built around. Okay. Any questions, Alan? Okay. Cool. I'll go ahead and stop recording then.